Alright, ladies and gentlemen, diving into 1.7 of our pre-calc talk, which we are opening up the discussion about combinations of functions. In my opinion, a very fun way to utilize a function and to understand what happens when there's a relationship between functions themselves. So within this section, our goals are to add and subtract functions, find domains of function quotients, find function compositions, and evaluate, honestly, some of these compositions as well, too. And so we're going to start off pretty basic with just understanding what does it mean to add two functions together, all right? And then once we have an evaluation, or once we have an addition, what does it look like to go ahead and then actually evaluate a specific combination? So let's take a look here at the example that you see on the screen to start some things on off with. So we want to go ahead and to basically find f plus g of x and evaluate it when x is equal to 1. Well, if you remember, guys, correctly from Algebra 2, guys, when you add or subtract functions together, they're just becoming polynomials, in which your goal is to start looking on into, do you have, all right, common themes anywhere? Do you have common or like terms in your polynomials? So let's go ahead and add these two functions on together. So we're going to be looking at f of x plus g of x, which is the same thing as 2x plus 1 plus x squared plus 2x minus 1. The ones will cancel on out. 2x and 2x give us a 4x. We get x squared plus 4x. Well, that's game, set, match. Well, what does the evaluation look like? Well, the evaluation in this case of f plus g of 1 is going to end up giving us 1 squared plus 4 times 1, or 1 plus 4, which is a value of 5. So what was the domain? So what's the domain of f plus g of x? So what about f plus g of x? What is the domain of this function specifically? Well, hopefully you understand that when you just simply went ahead and added these together, you get x squared plus 4x. That gives us no restrictions on x squared plus 4x. So in this case, the domain is going to end up being the set of all real numbers. Okay? All right, guys, let's continue to push forward a little bit and think about what are some other ways that we can combine functions together. So remember for a sec, all right, the domain of f and g actually does have to be considered when finding the sum, the difference, the product, or the quotient of f and g. Because think about it, when you combine two functions that have their own specific domains, the domains of the original f and the domains of the original g, or whatever function you're dealing with, don't all of a sudden disappear. They're still gonna actually be there. And so when you're combining them, you do still need to take into account what their specific domains are going to be. So let's take a look. Let's take f over g of x. So f over g of x is just the division of f of x over g of x, or in this case, root x over the root of 4 minus x squared. All right, so as you're kind of starting to look into this particular, function itself, there's not a whole lot we can do. We can get rid of the root in the denominator and things kind of like that, but not overly what I'm concerned with at the moment. All right, what I want to do first and foremost is start thinking of what the domain of f over g is in comparison to what g over f is. So let's go ahead and just go ahead and find out what g over f is first and see about comparing the domains that we're dealing with. All right. Well, once again, this is g of x over f of x. And again, we don't really have a whole lot to simplify here. We can, of course, get the radical out of the denominator by rationalizing it, but I want to hold off because it's going to show us our domain a little bit easier as well, too. So think about what the domain of f actually is, okay? So So the domain of f in this case, we can't have negatives under that radical, so we know that it's going to be 0 on to infinity. All right, and then think about what is the domain of g specifically. Well, the domain of g, well, you can't have, because we have this x squared term, we can't give ourselves any values in which 4 minus that value will become less than 0. And so when you think about it, negative 2 to 2 is about where you're going to be limited at. And so we're going to be stopping from negative 2 on to 2. All right. And so what you want to start looking on into is where is the intersection of these domains specifically. All right, so for the domain of f over g, the domain of g over x, you're going to start finding in where that domain has the intersections between them. Well, where is the intersection between 0 to infinity and negative 2 to 2? Well, hopefully for the domain here, you understand that that's going to be end up founding at from 0 to 2. All right, from 0 to 2. And hopefully you see why we have made that a open bracket for the domain here. Because if I were to substitute 2 on into my denominator, 0, and that holds us a problem in there. Well, what about the domain for g over f? Well, once again, that intersection, 0 to 2. Do you see the difference, though? Notice the difference between the two domains. Do you know why they are different? What causes them to have that slight difference on in there? That's the question. Think about it. What changes when we have 0 now as being a possibility? Now all of a sudden we can't throw 0 in the denominator. That's why we are not including it within the bracket itself. All right, ladies and gentlemen, that's going to wrap on up our talk about combinations using adding, subtracting, multiplying, and dividing. Now we looked at some examples of adding and dividing, but the same thing holds true for all of our different operations. In the next video, we're going to start diving on into compositions of functions, and we're on to the next one.